In this video, we're going to try and find the gradient formula for y equals x to the power 3. So what that means is you draw your graph y equals x to the power 3, and we want the gradient formula, meaning we want the ability to work out the gradient at anywhere on this curve. So to do this, we would set up 2 points at x and x plus h. So set up 2 points. And the coordinates here will be x comma x to the power 3. The coordinates here will be this much across, x plus h across, comma, and how high up is it? Well, you would put this into the x, so that would be x plus h all to the power 3. So if you want to know dy by dx, you would get the height divided by the cross. So basically you want to know the gradient of this straight line here. What is the gradient of this straight line? Well, the gradient would be the height divided by the cross. The height would be from here to here, which will be this thing here, take away from here to here. So this height here would be me getting this whole height, which will be x plus h all to the power 3. That would mean I would jump to here, and then I would need to take away this gap here. This gap here is x to the power 3. X to the power 3. So the gap there would be take away x to the power 3. So this thing here gives me the height divided by the cross. Well, we're going to call this length here h. X plus h. Hence the reason why this location is x plus h. Well, this length here would be h. So the gradient of this straight line will be given by this. Now we want to get the dot, this dot here, to move closer and closer to this dot. So we would take the limit as h tends to 0. That then would give us dy by dx, the true gradient. So the true gradient is us working out this limit. So to work out this limit, we would multiply this out. So to multiply this out, I would need Pascal's triangle. So use whichever method you want. So Pascal's triangle, adding these two together would be 3, 3. So these would be my coefficients, and I'm expecting you to be able to multiply this out. So this would be, lim as h tends to 0, and then you've got h, and then you've got this x to the power 3 over here. And then to multiply this out, the coefficient would be 1 x to the power 3 plus 3, and then the x goes down by 1, the h goes up by 1, and then plus this 3 now, 3, and then 3, and then the x goes down by 1, the h goes up by 1, so h and then h squared, and the last coefficient would be 1, 1, and then h to the power 3, and then we've got take away this thing here. So we would cancel these two out. That would then give us this. We can't simply put h into here because we're going to get 0 over 0. But notice that h is in common, h is in common, h is in common. So factor out the h. So lim as h tends to 0, factor out the h at the top. So h bracket, plus. So this times what will give me this. It's actually 3x squared. This times what will give me this. It's actually 3xh. And then this times what will give me this is actually h to the power of 2. And then you've got this h at the bottom. So now these two will cancel each other out. And then that will then give us this thing here. So lim of this thing here. Now take the limit as h tends to 0. So you would put 0 into the h. So with 0 times x times this thing here would disappear. Put 0 into here, this thing would disappear. All that would be left would be this thing here, 3x squared. So your dy by dx, the true gradient, is given by this thing here. So what that means is if you have x to the power 3, and let's say you're at 2 here, what is the gradient right here? Well, you can use the gradient formula. imagine you're standing here. What is the gradient right here? Well, put 2 into the gradient formula, into your dy by dx, because dy by dx represents a true gradient. So put 2 into here. 2 squared will be 4 times 3 will be 12. So the gradient here is actually 12. That is your gradient right there. So the gradient right here is written like this. dy by dx, evaluate it at x equals 2. We'll now put 2 into here. This would be 4 times 3. So it would be 12. So what that means is dy by dx, the gradient right here at x equals 2 is actually 12. Okay?